Hello everyone, welcome to Math 115, College Algebra. This is a video lecture on section 2.5 from your textbook, which is on quadratic equations. So we're going to review and go over how to solve quadratic equations. We're going to use a few different methods. First, we'll talk about factoring, right? Remember, we've already reviewed how to factor back in chapter 1. We'll talk about using the square root method. And then for more complicated problems, we can always use what's called the quadratic formula. And then I'll kind of just briefly mention completing the square. You don't necessarily need to know how to complete the square because you can always use the quadratic formula once you have the quadratic formula. Okay, so to start, first thing is, what is a quadratic equation? It's an equation that has this form right here, where it's ax squared plus bx plus c equals 0. And the thing that makes it quadratic is the squared term, right? The variable is raised to the second power. As opposed to linear equations, which we talked about earlier, was just raised to the first power. Quadratic equation, it's raised to the second power. Now, whenever you're solving a quadratic equation, you always have to set the equation equal to 0. Why is that? Well, let's say I have two factors. So ultimately, we're going to try and factor that left-hand side. And let's say we have two factors, a and b, and when you multiply them, you get 0. What does that mean? Well, first of all, so if capital A, let's say that's the first factor, times the second factor equals 0, then either A equals 0 or B equals 0. Right, or both. So that's going to allow us to solve for the variable. So, for example, let's say you're given a quadratic equation and you factor left-hand side and you get x plus 7 times x minus 11 equals 0. Okay, so you factor the left-hand side and that's what you got. So, in order for that to be true, right, either this factor, x plus 7, must be 0 because then 0 times anything will give me 0. Or this factor, x minus 11, must be 0, right? Because then anything times 0 gives me 0. So you have to try both possibilities, right? You have to carry out both possibilities. So again, one possibility is x plus 7 is equal to 0. And if I subtract 7 from both sides, that'll give me the solution x equals negative 7. And then the other possibility is x minus 11 equals 0. And if I add 11 to both sides, then I'll get the solution x equals 11. Right, so that'll give me the two solutions. So in order to solve it, you have to set the quadratic equation equal to 0. Okay, so let's try some of these. And again, we already reviewed factoring, right? So this is going to use our factoring skills. Let's say I want to solve, so example 1, I want to solve x squared minus 5x minus 6 equals 0. So first thing, it's already set equal to 0, right? So we don't have to do anything there. Let's try factoring the left-hand side. Well, since the a is a 1, right? The coefficient of the x squared term is a 1, then I can just use the BC rule. Hopefully it'll work. So the only way I can get x squared is x times x. Then I want to think of two things when multiplied will give me negative 6, and then when added will give me negative 5. Well, if I do negative 6 times positive 1, that'll work, right? Negative 6 times positive 1 is negative 6. Negative 6 plus a positive 1 is negative 5. So one of these is going to be negative 6, doesn't matter what order, and the other one is a positive 1. So then I can say, okay, since I have something, right, some factor times another factor equals 0, then I can set the first factor equal to 0 and solve it. So if I add 6, this will give me x equals 6. So that's one solution. And I can set the second factor equal to 0. Right? That's another possibility and solve it. In that case, I'm going to get x equals negative 1. And you could always check this, right? You could check it. Here, I'll do a check over here. By plugging the solutions back in, right? And see if you get a true statement. So where I have an x, I'll plug in 6 I'll put a question mark here. Does that equal 0? Well, this is 36, right? Minus 30 minus 6. Yeah, that's going to be 6 minus 6. That's 36 minus 36. That's 0 is equal to 0. So that checks. And if I plug in a negative 1, again, I'll put a question mark there. So negative 1 squared is positive 1. Negative 5 times negative 1 is positive 5. And I have a minus 6. Yeah, that's 6 minus 6. That's 0, right? So that checks. So we know both of them are solutions. So you can always check them if you want to see if they actually are solutions. Okay, next example. So this one, it's not set equal to 0, right? So the first thing you want to do is set it equal to 0. So I will move the 49. I'll subtract it from both sides. So I have 36x squared minus 49 is equal to 0. And recognize that this is a difference of squares, right? Remember, it has that special form a squared minus b squared. And this factors into a plus b times a minus b. It's really useful to recognize that form. So in this case, I can think of this as 6x all squared minus 7 squared, right? 49 is 7 squared equals 0. So this is going to factor into 6x plus 7, right? A plus b, and then 6x minus 7, a minus b is equal to 0. So to solve it for x, I set each of these factors equal to 0, right? So I have 6x plus 7 equals 0. I'll subtract 7 from both sides. So 6x equals negative 7. And then finally, to get x, I need to divide by positive 6. So x equals negative 7 sixths. And then I need to set the other one equal to 0. So 6x minus 7 is equal to 0. So I add 7. So 6x is equal to 7. Divide by 6. So x is equal to positive 7 sixths. And those are my two solutions. Right? If you were to plug those back into the original quadratic equation here, it would solve both of them, right? It'd be true for both x equals negative 7 sixths and x equals positive 7 sixths. All right, let's do a few more of these. Let's see, in this case, so I need to set it equal to 0, right? So I'm going to add 2 to both sides. So I have 12x squared plus 11x plus 2 is equal to 0, right? Remember, always set it equal to 0 first. Okay, now this one, a little more complicated. We're going to have to, we don't have a 1 as our a, right, in front of the x squared term, so we're going to have to use our AC rule. So remember how to do that. If I multiply a times c, so positive 12 times positive 2, I'm going to get 24. And then I want to think of two things that multiplied give me 24 and added give me positive 11. So if you go through all the possibilities, like 24 times 1, that's not going to work. Negative 24 times negative 1, that's not going to work. 12 and 2, no, that won't work. I guess 8 and 3 will work, right? And I want them both to be positive because I want my product to be a positive 24 and I want my sum to be a positive 11, right? You want to add to that b term. So now I rewrite that middle term in terms of those two factors I just found. So 11x can be written as 8x plus 3x. Then remember the next step is to group, right? Because we have 4 terms, so we group. Factor out as much as I can from that first group, which in this case is going to be, I can pull out 4x. And I'm left with 3x plus 2. And hopefully I'm left with 3x plus 2 if I factor something out of the second group. And actually, since I already have 3x plus 2, the way to think about it is really you factored out a positive 1, right? We didn't really do anything, but that's the same as saying we factored out a positive 1. And now, since that factor is common to both, right, it's common to this term and common to this term, I can factor it out front. And I'm left with 4x plus 1. Okay, now I can set each of those equal to 0, right? So one possibility is, I'll do it over here, 3x plus 2 is equal to 0. And if I solve that, I'm going to get 3x equals negative 2 divided by 3. Looks like x is equal to negative 2/3. So that's one solution. And then if I set 4x plus 1 is equal to 0, I'll subtract 1 and then divide by positive 4. So x in this case is equal to negative 1/4. So those are my two solutions. Okay, in this next one, first of all, this doesn't look quadratic, right? It's cubic, but notice there's an x that's common to every term, right? It's like the greatest common factor of every term. So we can factor out the x. And first of all, it's already set equal to 0, right? So we don't have to do anything else there. So this is truly not quadratic, but because x is common to every term, I can pull it out front. Let me just write it down again. And then what remains is quadratic, right? I'm going to get x squared plus 11x plus 10 is equal to 0. Okay, so you have to keep that x that you pulled out, and then this is just the BC rule, right? So I have x. I want two things when multiplied will give me positive 10, and when added will give me positive 11. Well, plus 10 and plus 1 will work. But now I have three possibilities, right? One possibility is x could equal 0. The other possibility is x plus 10 could equal 0. And the other possibility is x plus 1 could equal 0. The first one's done, right? So that is one of the solutions, x equals 0. And notice, if we plug 0 back in here, right, each of these terms is going to disappear. 0 cubed is 0. 11 times 0 squared is 0. 10 times 0 is 0. So 0 equals 0. That checks. So that is a solution. Then if I solve this one, I'll subtract 10. So x equals negative 10. That's another solution. And then finally, if I subtract 1 here, I have x equals negative 1. So those are my three solutions in this case to that equation. Happens to be a cubic equation in this case. Okay, another technique that can be used, especially, so and this actually works if there's no x term, there's no linear term, right? So there's no b, or if you say b is equal to 0. So if you have a case where there's no linear term, right? The b is 0, so there's no x term, right? In other words, you could write it as ax squared plus c equals 0, right? There's no bx there. You can rewrite this so that you end up with x squared equals a constant, right? You can bring the c to the other side and divide by a, so you're going to get x squared equals a constant. And then the way to solve that is illustrated here. So you would take the square root of both sides. And then technically the square root of x squared is the absolute value of x. So that's going to equal radical k. And then the x itself could be positive or negative, right? You have to account for both possibilities. Okay, so for instance, if you had something like this, if you had, let's say x squared is equal to 5, let's say, then I can take the square root of both sides, but then immediately, so you don't worry about the absolute value term here, just immediately put a plus or a minus, right? Because it could be positive, it could be negative. So you're going to get x equals plus or minus, and I can't really do much more with the square root of 5. So those are my two solutions, right? Either x equals positive square root of 5 or x equals negative square root of 5. And notice if I plug them both back in to here for x, if I plug in radical 5 and I square it, I'm going to get 5. And if I plug in negative radical 5 and I square it, because I have negative radical 5 times negative radical 5, I'm still going to get positive 5. So that's why we have to have plus or minus. Okay, but technically it comes from the fact that the square root of x squared is really the absolute value of x. Okay, so in this case, if we're going to use the square root method, we basically have to isolate the x squared term. So in this example, example 5, I want to move the 81 to the other side. So I'm going to add 81 to both sides. And now I have the x squared term isolated. So now to get x by itself, I need to take the square root But when I take the square root, I have to account for the fact that it could be positive or negative. And then it just so happens that the square root of 81 is a perfect, 81 is a perfect square, right? So square root of 81 is just 9. So then my two solutions are x equals positive 9 and an x equals negative 9, right? Or you could just leave it like this, plus or minus 9, and that means this, x equals positive 9, x equals negative 9. Okay, let's do a couple more with this, with the square root property. So in this case, we don't actually want to isolate the x squared. Like, we don't want to expand this out. And you'll see why in a second. We're just going to isolate this squared factor term here. So to do that, I need to first divide by 3. Right, I'm going to get rid of that 3, so I'll divide both sides by 3. So I'm going to get x minus 4 all squared equals 5. Okay, so that's what I want to do. In a lot of cases, you're going to end up with just x squared on the side, but in this case, we have a whole factor squared. As long as we isolate the something squared, right? In this case, it's the entire factor x minus 4 squared is equal to positive 5. So now we would apply the square root property. So I would take the square root of both sides. And remember, we have to account for the fact that it could be plus or minus. And so now I'm going to end up with x minus 4, right? Square root of x minus 4 squared is x minus 4 equals plus or minus radical 5. And then to get x by itself, I need to do one more step. I need to add 4 to both sides. So one solution is x equals 4 plus radical 5. And the other solution is going to be x is equal to 4 minus radical 5. Right? Because I have 4 plus or minus the square root of 5. So I split them up. X equals 4 plus radical 5 and x equals 4 minus radical 5. Okay, and then here we'll do another one. Same thing. In this case, I can isolate the x squared term, right, by dividing both sides by 5. So I'm going to get x squared is equal to, what's that, 12, right? 60 divided by 5. Use the square root property. Don't forget that it could be positive or negative. And then probably want to simplify this. Okay, and we kind of reviewed this earlier too. Remember, 12 factors into 2 times 6, 2 times 3. So you can think of square root of 12 is square root of 2 times 2 times 3, and we can pull out a 2, right? Pull out a pair as a single 2. So you could write this as x equals plus or minus 2 radical 3. So basically that says that one solution is x equals positive 2 radical 3, and the other solution is x equals negative 2 radical 3. Those would be the two solutions. Okay, what if we have something that's more complicated that we can't easily factor? Because there should always be, for any quadratic equation, there should always be two solutions. They may not be real number solutions, right? They may be, or they may actually even be the same solution. That's another possibility too, right? But they could also be complex number solutions. So they could be real number solutions, complex number solutions, or they could be the same real number solution. So if you have something more complicated, then what you do is you just turn to something called the quadratic formula. Okay. So what this says, and I have it remind you of what that is here. So if you have a general quadratic equation, right, ax squared plus bx plus c equals 0, then the solution x is always going to be this. You just have to plug into this formula. It's going to be minus b, so minus the coefficient of the x term, plus or minus the square root of b squared minus 4 times a, the coefficient of the x squared term, and then times c, times the constant, over 2 times a. Again, a is the coefficient of the x squared term. Okay, remember b is the coefficient of the x term, a is the coefficient of the x squared term, and c is the constant. So you literally just plug into that formula, and that will give you the solutions for x. It'll give you both solutions, right? The plus or minus here is why you're going to get both solutions. Where does this come from? It actually comes from something called completing the square, which I'm just going to touch on slightly. We'll do one example at the end here where we complete the square. But maybe what I'll do as a bonus is I'll derive this formula for you from completing the square, just to show you that it's not mysterious. It actually comes from doing something, completing the square. But it's very useful. This is something you want to write down on your cheat sheet because it's going to be helpful. Okay, so in this case, it turns out it's not easy to factor this, right? So I have a quadratic equation. It's set equal to 0, right? So it's in that form, ax squared plus bx plus c equals 0. It turns out it's not easy to factor it. So what I can do is I'm just going to solve it using the quadratic formula. So the first thing I should do is figure out what a, b, and c are. Well, a is the coefficient of the x squared term, which in this case is just a 1, right? So a is 1. B is the coefficient of the x term, that also happens to be a 1. And then c is the constant, which is a 2. So now I plug in, right? I have x equals, I'll write it out again, minus b plus or minus the square root of b squared minus 4ac all over 2a. So x equals minus 1, right? Remember b is 1, plus or minus the square root of 1 squared minus 4 times 1 times 2 all over 2 and then times a, which is 1 again. And then if you work this out, right, so if you do the arithmetic inside the radical there, I'm going to have 1 squared, which is 1, minus 4 times 1 times 2, which is 8, over 2 times 1, which is 2. But 1 minus 8 is negative 7. And remember, what's the square root of negative 7? Well, that's going to be an imaginary number, right? I'll write it over here again. So I have x equals minus 1 plus or minus the square root of negative 7 all over 2. So I can't really do anything with the square root, so I'll leave it as square root of 7. But then the square root of the negative 1 is I, right, over 2. So really the solutions are going to be x is equal to negative 1 plus radical 7i all over 2, or x equals negative 1 minus radical 7 times I all over 2, right? Those are the two solutions. So yeah, we had a quadratic equation and we ended up with two solutions, and they end up being complex solutions. And an interesting point is, notice when they're complex solutions, they're always going to be complex conjugates of one another. See how the only thing that's changed here is the sign of the imaginary term has changed, right? So these are complex conjugates of one another. Okay, here's another example using quadratic formula. So in this case, it's already set equal to 0, so that's fine. And then the a is 9, the b is 3, and the c is negative 2. So in terms of the quadratic formula, I have x equals, I'll write it out again, minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be x equals minus 3 plus or minus the square root of 3 squared minus 4 times 9 times negative 2 all over 2 times 9. right? 2a, and a is 9. All right, so if we start simplifying things here, this is going to be minus 3 plus or minus the square root. This is, I guess, 9. And then negative 4 times 9 times negative 2 is positive 72, I guess. All over 2 times 9, which is 18. So then we can go further here. Oh, this is nice, right? 9 plus 72 is 81. 81 is a perfect square. So this is really the same as negative 3 plus or minus 9 over 18. So one solution is negative 3 plus 9 over 18. Well, that'll be what? 6 over 18? Which is 1/3. So one solution is x equals 1/3. So just we got a real number solution. And the other possibility is x equals minus 3 minus 9. So negative 3 minus 9 over 18. That's negative 12 over 18, which is negative, I guess 6 goes into both of them, right? Negative 2/3. So in this case, we happen to get 2 real solutions. But it wasn't easy to factor, so we had to use the quadratic formula. Okay, let's just briefly talk about completing the square. So technically, completing the square will also work for any quadratic equation, and it'll give you, either 2 real solutions, a double real solution, right? It could be the same real solution, or the 2 complex solutions. They're going to be complex conjugates of one another. But it's best and easiest to use when you complete the square if the a is equal to a 1. Okay? So if the a is equal to 1, and you can't easily factor. So in this case, right, if we try to think of 2 things and multiply give us positive 1 and add to give us positive 4, we can't think of those 2 things, right? We can't easily factor that. So in that case, we could use what's called completing the square. And let me just briefly show you how this works. So what you would do is you would move the constant to the right-hand side. So right now I have it set equal to 0, right? Like I should for a quadratic equation. But I'm purposely going to move the constant to the right-hand side. So I'm going to subtract 1 from both sides. So I have x squared plus 4x equals minus 1. Now, what we want to do is we want to try and rewrite the left-hand side so we end up with what's called a perfect square trinomial, right? It's going to be 3 terms that's going to end up being a perfect square. All right, sometimes you could write it like this. So we're going to end up with something that's like x squared plus 2dx plus d squared, and that's the same as x plus d squared. Remember we talked about actually a perfect square trinomial as one of the special factors, right, that you could come up with. So that's our goal, is to end up with a perfect square trinomial. And the way to do that is you add a term to both sides. And what that term is, it's basically half of the b term, or half of the coefficient of the x term, squared. You want to add that to both sides. So I'll write it over here. I'll say add half of b, so half times b, or you could think of it as b over 2, squared to both sides. So what is b in this case? It's 4. What's half of 4? That's 2. What's 2 squared? So in this case, I want half of 4, right, squared, which is 2 squared, which is 4. I want to add 4 to both sides. Okay, and I can do that because I'm just adding the same number to both sides, right? Whatever you do to one side, do the other side, and it doesn't change the equation itself. Then it turns out that this left-hand side is now a perfect square trinomial. This is always going to be x plus b over 2 squared. Remember, b was 4. Right, so I'll put it here. The left side becomes x plus b over 2 squared. So in our case, it was x plus 4 over 2 squared, but that's just x plus 2, right, squared. And you can check yourself, right? If you were to FOIL this back out, x plus 2 squared means x plus 2 times x plus 2, right? If you FOIL it back out, you're going to get x squared plus 4x plus 4. It was one of our special factorizations, that's all. On the right-hand side, so remember I had to add 4. What's negative 1 plus 4? That's positive 3. And notice, now we have the form where we can use the square root property, right? This is exactly the form that we want for the square root property. So now I can take the square root of both sides. Don't forget that it could be positive or negative. So I'm left with x plus 2, right? Square root of x plus 2 squared is just x plus 2 equals plus or minus radical 3. And now to get x by itself, I'm just going to subtract 2 from both sides. So one solution is x equals negative 2 plus radical 3. And the other solution is x equals negative 2 minus radical 3. It doesn't matter what order you write them. Sometimes I write the negative first. So x equals negative 2 plus radical 3, x equals negative 2 minus radical 3. And those are real numbers, right? There's no i's in there, so those are real numbers. But there's no way that we could have factored it. In fact, we couldn't think of two things and multiplied give us 1 and added give us 4. So we had to turn to something else. So we solved it by completing the square. But if you don't remember how to complete the square, or this is confusing, just use the quadratic formula. Okay? All right, so as a bonus, let me do one more thing as a bonus here. Let me derive the quadratic formula from completing the square. Okay, so if we have our original, let me make this a little bigger here. Let's say I have my original equation, x squared, ax squared plus bx plus c is equal to 0. And I want to solve that for x, right? But I want to do it in general, so it'll work for every case. So if I want to use completing the square, I first have to get the constant to the other side, so I'll subtract c from both sides. So I'm going to have ax squared plus bx is equal to minus c. And remember, we said that this really works best if we have a 1 in front of the x squared term when we're trying to complete the square. And right now I have an a there, but I can easily get a 1 if I just divide everything by a, right? I'll divide both sides of the equation by a. So now I'm going to have x squared, right, because a over a is 1, plus b over a x equals minus c over a. And now I want to add half of, I can't really call it b now because it's b over a, but it's half of the coefficient of the x term squared to both sides. So I want to add half of b over a squared to both sides. Okay, and what is that? Well, that's going to be, if I square that, right, it'll be b squared over 4a squared, right, to both sides. Right, it's b over 2a squared, so b over 2a times itself is b squared over 4a squared. So this will be and I'll add it to the other side. I'll put it in first term. So b squared over 4a squared minus c over a. Okay, now it turns out that that left-hand side is now a perfect square trinomial, right? This actually is, and you can check it, x plus half of that term, so b over 2a squared, right? FOIL it back out and you'll get this, what we started with. So that it actually is this squared. And then the right hand side, I'm going to subtract those by writing them so they have the same denominator. Remember, when we subtract fractions, we have to have the same denominator. So in order to get 4a squared from my denominator, I'm missing a 4a here, so I need to multiply the numerator by 4a. So you can think of this as, this is going to be b squared minus, I'll write it as 4ac, all divided by 4a squared. Okay, now we apply the square root property. So I take the square root of both sides, remembering that it could be positive or negative. Okay, so left-hand side, this is just going to be x plus b over 2a. And the right-hand side, notice that this is the same as square root of b squared minus 4ac over the square root of 4a squared. But the square root of 4a squared is equal to 2a, right? So the right-hand side is going to be, I still have the plus or minus. For the numerator, I'll just leave it square root of b squared minus 4a squared. But the denominator, the square root of 4a squared, is just 2a. And then finally, I can subtract b over 2a from both sides. So I'm going to get x equals minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then since they have the same denominator, I can basically like combine the numerators, right? So I could say this is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And that, you notice, is the quadratic formula. So really it just comes from completing the square. Completing the square is really the important thing, okay? But sometimes it's a pain to remember all the steps, how to do that. So if you get something that you can't easily factor, right, or if it doesn't have the form where you can use the square root property, you should just use the quadratic formula, okay? But I wanted to show you like where it came from. All right, great. Next, we'll talk about section 2.6, which is other types of equations. Just a few other types of equations we'll explore. And then the last section that we're going to talk about in chapter 2 is going to be 2.7, which is on linear inequalities and some absolute value inequalities. Okay, and then we'll end up going eventually into chapter 3. We'll talk about functions. Okay, great. Thanks.